Okay. Okay. Let me check. I didn't check register. Check. Okay. So now we're going to do my favorite segment, the segment where we see if is there any other way for us to find the same solution. Okay. So the final product is this. You have got only that. Okay. So let us see. You have got this. Okay, let me try and do this. Okay, t to the 6 plus 1 t to the 6 plus t. Let me say I've got t to the 6. So let me try and find this here. Okay, so I can write this as plus t cubed minus t cubed plus 1 all over t to the 6 plus t. Okay, do you see what happened here, guys? Okay, here, this thing just represents 0. It's more like I didn't put it there. It's just equals to 0 because it's more like 1 minus 1. Okay, I just introduced a 0 term. But that 0 term, I introduced it in a beautiful way such that it can be able to be manipulated with respect to this. Okay, so this thing is only motivated because I found that solution using long division as 1 plus negative t cubed plus 1 all over t to the 6 plus t cubed. That's why I motivated this solution. Okay, so what's going to happen is I'm going to have t to the 6 plus t cubed. Okay, and then separate it and have t to the 6 plus t cubed, and then have plus minus t cubed plus 1 all over t to the 6 plus t cubed. Do you see what happened? I just separated these terms and took this one, this side, and took this one, that side. This is what I did. And do you see, and do you believe that this thing and that thing are exactly the same? Because when you divide the two, you get 1. Okay, I hope you can see that the corner plus negative t cubed plus 1 all over t to the 6th plus t cubed. Now I'm motivated that mathematical manipulation does work and mathematical manipulation is true. Okay, so we're going to go through the same steps and see, but I do not need to prove it to you anymore because if this thing in this way can give us the same solution as long division, then therefore we can say that this thing is definitely going to give us the same solution. But for purposes of me trying to make sure that you are 100% convinced that this thing is the same, I'm just going to browse through it very quick. T cubed plus t cubed plus 1, which is going to be 1 plus negative t cubed plus 1 all over t cubed, and then have t plus 1 and have t squared minus t plus 1. Okay, this is what I said, they must interchange. Okay, so this will just give us this. Okay, because if you can check this thing out, we're only going to consider this part, negative t cubed plus 1 all over t cubed, t plus 1, and have t squared minus t plus 1. So this will give us exactly this, which is just a over t plus b all over t squared plus c all over t cubed plus d all over t plus 1. And then we're going to have ex plus f all over t squared minus t plus 1. Okay, so I've convinced you enough that mathematical manipulation also does work. Okay, because we can see as much as we introduced that 0 term, that 0 term was just there to manipulate the whole solution to come out as what we wanted to. Because we knew or we saw by long division that the solution is going to be given by that particular thing. Okay. So who is not convinced such that we can do another question and can solve? Okay. If you're not convinced, please do let me know. But if you're convinced, you can go and do the actual questions of finding the integrals and stuff. Okay. So are we fine, guys? Are we convinced that this is the solution? Are we convinced that this thing is working? Any questions? Okay. Your silence tells me that you did not have a question. So let me take an integral now to solve. Okay. I didn't do number. Oh, okay. Please do this one. Okay. Please do this one. It doesn't matter how you do it. Doesn't matter how you do it, but I'm gonna need you to do it. It's either you use mathematical manipulation or you use long division. It really doesn't matter. Okay. X to the 5th plus 1 all over x squared minus x to the 4th plus 2x squared plus 1. Okay. So please do this one and submit it there by WhatsApp. Okay. Please submit it there. It is submitted today before 5. Okay. So I'll accept this thing until that. Okay. So this thing comes from your textbook. It's not something which I'm creating or something like that. It comes from the textbook. It's the second part of number 6. And they said number 6 is the hard question. Okay. But you are not there. Let me do number 23, which is also showing to be a hard problem. Yeah, let me do number 23. This is number 23, guys. You can't see it very well, so I'll just write it down. Okay, so please do this one. Okay, so number 23 becomes example number 5. Okay, becomes example number 5. So can I write this thing out? Can I wrap this thing out, guys? Because somebody sent a chat. Okay, you've got an electronic class. Okay, for you, okay, for everybody then it's fine. I'll give you until 8 o'clock to submit this. Okay, I'll give you until 8 o'clock to submit. Is it fine now? So that is your question, guys. Okay, that is your question, and I will do number 23. Okay, so let me wrap this thing out until 8, guys, please. Okay, so number 23 goes as follows. Okay, number 23 goes as follows. It's red. It has this red numbering, so I'll take that as hard. That's what it is according to the text. So this is 10 all over x minus 1 x squared plus 9 x. Okay. So this is a hard question. Okay. Now we're gonna have to solve it the way we've been solving these IOs. Okay. So I've got 10 all over x minus 1 x squared plus 9. Okay. I don't know why this is called a hard question, but hey, what can we say? Do you see that this thing is an irreducible quadratic okay? So since it's an irreducible quadratic, it means that there is nothing much we can do from here. What we have to do is one thing. We just have to write this thing in terms of the partial fraction decomposition, which is a over x minus 1, okay? Because the first part is linear vector plus bx plus c all over x squared plus 9. Okay, so it's an irreducible quadratic. And as you can see, we do not have any exponent there, which means it's not a, but just a linear. I nearly said linear. It's just an irreducible quadratic. Okay. So this irreducible quadratic factor, we can just do that thingy that we did last time, multiply each and every term by the denominator. Then when we do that, we find that 10 is equals to a, that we have x squared plus 9 plus bx plus c x minus 1. Okay. And then I said to you, okay, let us try to say let x be equals to 1, and let's see what's going to happen. Okay. If x is 1, we're going to have 10 is equals to a, 1 squared plus 9, plus b plus c, because b times 1 is just multiplied by 1 minus 1, and this is 0. So if this is 0, the whole thing becomes 0. Okay, thus becomes 10 is equals to 10a, and then this means that our a is equals to 1. Okay, this means that our a becomes 1. All right. So since our a is 1, we can find our b and our c. Okay? Fine. So we go back to this thing. Let me sort up, guys. Let me sorry. Now, what's going to happen is we're going to multiply out, okay, because like there's no other term we can use because this thing is not factorized. So we can't say our x in this case is plus or minus the square root of 9, negative 9. Negative 9. So let us just leave it. Okay, so we'll just expand this. So the expansion of this is just equals to 10 is equals to ax squared plus 9a. But our a, we know it, right? So what I can do is say, okay, since we know our a, we can have this as x squared plus 9 plus, we're going to have this thing, bx squared plus, minus bx, and then have c times x, which is cx, have minus c. Okay, so do you see that for me to find our c, I can say 10 is equals to 9 minus c, okay? Because these are the only constants we have here. So let me just do it like this. These are the only constants, and these are the only coefficient of x, and these are the coefficient of x squared. Okay, so we're just going to have 3 equations, but we do not have, okay, let me just not speak. So we're going to have this and have that one this side, and then I have 9 minus 10, which is minus 1. So our c is minus 1. Okay, now let us find our b. Our b is going to be found at this term. Okay, so this term has got another term this side, which is 0x. Okay, so we're going to say minus b plus c is equals to 0. Okay, because 0x correlates with everything that has got the coefficient of x. Now we're going to have negative b minus 1 is equals to c, and then our b is equals to negative 1. Do you agree? Because this one comes this side, so it becomes negative b is equals to 1. Then you divide by negative 1 on both sides. Okay, so are we fine with this idea, guys? Are we fine? So if you're not fine, please do let me know, and then I will re-explain it again, because I need to wrap this thing out. So yeah, okay, so our values of a is equals to 1, our b is equals to negative 1, our c is equals to negative. Okay, so let me wrap this thing out. Okay, so these things, they're just nice, guys. It's the same thing that we're doing for linear. It's just for linear, it's much simpler as compared to quadratics. Okay, quadratics are much tedious, but it's fine. So we remember that a is given by that, so we're gonna write this as 1 all over x minus 1. Okay, and then what is our b? Our b is negative 1 x minus 1 all over x squared minus, or x squared plus. Okay, so we can rewrite this as 1 over x minus 1, and then have minus x all over x squared plus 9, and then have minus 1 all over x squared plus 9. Okay, so there's nothing much you can do. Okay, there's nothing much. So we just have to take this and put it in the integral. So can I put this in an integral and have 1 over x minus 1 minus x all over x squared plus 9 minus 1 over x squared plus 9. Okay, all being x. Then we're gonna take these things individually. So and have the integral of 1 over x minus 1 x minus the integral of x over x squared plus 9x minus integral of 1 over x squared plus 9 dx. Okay, so we're going to have all of those things. So, and at the first part, we are just going to have ln. Okay, we're just going to have ln of the absolute value of x minus 1. Okay, okay, let me do, oh, it's fine, it's fine. Ln of the absolute value of x minus 1. Okay, and then here we're going to have the second part, we're going to have 1/2. Now I'm doing this thing using my head, guys. Okay, why? Is because I know that here we cannot use ln properties yet. We have to use let u equals to x squared plus 9. Our du is equals to 2x x. Then we're going to have du over 2 is equals to x dx, and our x dx is 10 right. So u over 2. So we're going to have 1 over u du over 2, and then we take that 1 over 2 outside. It becomes 1 over 2 integral of 1 over u du, which becomes ln, using it. Then we're going to have ln of u, but our u is x squared plus 9. Okay, then our last part, we're going to have, now, when you look at this one, we're having x squared plus 9, okay? And according to what we did with integrals last year, this term is a squared, okay? This term is a squared. So a squared in this case, we're going to take the square root of 9, which is going to be 3, and we have arctan x over 3. Okay. So this becomes the solution. This is number 23. Let's see if we found the solution. Okay. Let's see if we found the solution. Okay, I don't need to do it. But they can make it a bit beautiful. I love how they solve this question. This is number 23. Okay. Oh, they actually left it the way I left it. I love it. Okay. So this is the solution for number 23 over here. You see. So number 23 is this one. They found the solution of ln of absolute value of x minus 1 minus 1/2 ln of x squared minus 9 minus 1/3 arctan x over 3 plus c, which is the same solution I got for you guys. This one. Okay. So if you are not convinced even now, then I don't know. Okay. So let us see if there's anyone who has got a question before I can do another one, which is number 31. Is there any questions, guys, we have based on the examples that we have? Okay. In the absence of questions or queries or anything like that, let's just go to our final example. Just go to our final example, example number 6. Okay. Example number 6, I'll take it as number 31. Okay. Number 31 is also given this red thing, red numbering, red tag, and therefore we're gonna fight with this hard solution in this hard question. So number 31 is given by the integral of 1 over x cubed minus 1 dx. Yeah. So we're gonna put that theory that I gave you to the test now, if whether is it true or not. Okay, and I put the theory to the test. Is it really what we think it is, or was I just speaking because we have to speak? Okay, so we're going to have this one. 1 over x cubed minus 1. I said you can write this as x minus 1, and I have x squared plus x plus 1. Okay, so is this thing as true as I say it is? Okay, so we're gonna check. We're gonna do a all over x minus 1 plus bx plus c all over x squared plus x plus 1. Okay, so what's going to happen from here is we're going to multiply on both sides with the denominator. We're going to have 1 is equals to a times x squared plus x plus 1. And then we're going to have plus bx plus c multiplied by x minus 1. So this is multiplication. Okay, so I said to you, we're going to let x be equals to 1. Okay, and let x is equals to 1. Then what we are having here is 1 is equals to a, 1 plus 1 plus 1 plus b plus c times 1 minus 1, which this whole term is 0. Then this becomes 3a. 1 is equals to 3a. That becomes a is equals to 1/3. Okay, a becomes 1/3. So we found the first value. Our a is equals to 1/3. Okay, now let us check for b and c. Okay, so 1/3. Okay, now let us see the expansion of this. The expansion of this is just bx squared, okay, minus bx plus cx minus c. Okay, so this is just the expansion of this. So this expansion is just 1/3 x cubed, 1/3 x squared plus 1/3 x plus 1/3. Okay, because I'm trying to check how am I going to approach this one. Okay, so for me to find b or c, c is given by negative c plus 1/3, which is equals to 1. Okay, so 1 is equals to 1/3 minus c. Okay, so you're going to take this c this side and take this 1 this side. Then c becomes 1/3 minus 1. Our c becomes negative 2/3. Okay, our c becomes negative 2/3. So let us find our b now. Okay, so b is given mostly by this one, which is in terms of x, by this term in terms of x. So therefore, I'm going to have negative b plus c is equals to 0 because the coefficient of x is just 0 on the side. So therefore, our c is already given. Our negative b minus 2/3 is equals to 0. Take b that side. And then what's going to happen? No, wait. Oh, I forgot another term, guys, okay? Because this 1/3 also plays a part here. So it's just going to be a minus b plus c, okay? A, because it's this one, it's also having the coefficient of x. This is ax squared plus ax plus a, okay? So it's going to be a minus b plus c is equals to 0. As you can see, okay? I made terrible mistakes. Okay, please explain this before you let to be equals to 1. Please. I nearly made terrible mistakes. So our a is 1/3, our b is the unknown, and our c is negative 2/3, which is equals to 0. Then b is negative, so it becomes a positive. 1/3 minus 2/3. I don't know what is the solution to this. Okay, 1/3 minus 2/3. Oh, I can actually check. It becomes 1 minus 2 all over 3, which is minus 1 over 3. Okay, so b is minus 1 over 3. Okay, so our a is 1/3, our b is minus 1/3, and our c is minus 2/3. Okay, so I'm gonna rub this thing out, guys. Okay, I'm gonna rub this thing out, and then we're gonna find the exact solution. Okay, but are we fine so far, guys? Are you all well? Are you all yeah, taken care of? Are you all? Yeah. Okay, let us continue. So this, don't worry guys, I'm gonna upload this to the YouTube channel. If you didn't see some of the things I wrote, go and check. Okay. So this, our A is 1/3 all over x minus 1. Our B is negative 1/3 x minus 2/3 all over x squared plus x plus 1. Okay. Mathematically, we don't like writing like this. So what we're gonna do is we can say, why not write this as 1/3 1 over x minus 1 and separate, but I don't need to separate these two. I definitely need to separate these two. So I can just say minus 1/3 and have x minus 2 all over x squared minus, x squared plus x plus 1. Okay, x squared plus x plus 1. Okay, so this times that is just this. This times that it becomes, it becomes plus. Okay, so this becomes x part. So now the final part is we're going to integrate this. So it becomes 1/3 and have 1 over x minus 1 x. I'm already separating terms, guys. Okay, I'm already separating terms. X plus 2 over x squared plus x plus 1 x. Okay, so we can hear there is a lot, but let me separate it. I feel like I should separate it. Okay, I just have this strong feeling that maybe, just maybe, I should separate it. Okay, because of that feeling, let me separate it. Okay, so I have x squared plus x plus 1 x, then I'm going to minus 1/3 2 x squared plus x plus 1. Okay, so in this particular case, you're going to use U substitution here, and here we are going to complete the square here. Okay, here we're going to complete the square because there is nothing much you can do. As we complete the square, we are trying to find the arctan solution. Remember the one that looks like this one. Okay, so for the U substitution, we're gonna let U equals to x squared plus x plus 1. Then our du is equals to 2x plus 1. Okay, then this is multiplied. But now I do not have this, I have only x dx, so it becomes what do you call this? Okay, or can approach this so this as x plus 1/2. Okay, yeah, because now when this I divide each and every term by 2. If I divide each and every term by 2, go to du over 2. Okay, du over 2 is equals to x plus 1/2 x. Okay, so I can just have this here instead of it. Okay, so okay, so we are running out of time, guys, here. Yeah? Okay, so what I'll do is I'll just complete this thing. Okay, just complete this thing, then I'll send it in our chat. But so far, guys, I'll find it the idea that I was today, and if not, please send a message to the group chat, and I'll upload this video maybe tomorrow. As for today, let's just leave it here. Guys, please have a wonderful Heritage Day, and please be safe, take care of yourselves, and thank you very much for attending this session. Take care. Any question for Riley?
No, we're good.
Okay, no, that's fine. Thank you very much, guys. Have a nice day. Thank you.